Welcome to Symmetric Space. Okay, so today we continue with the question number 10 in class 12 NCERT exercise 1.1. Okay, so what is given? Given example of a relation which is symmetric but neither reflexive nor transitive. Okay, so we have to find a relation, okay, which is only symmetric. Fine. So what is symmetric? X comma y and y comma x should belong into the R. Fine. So let's assume some set as 5, 6, 7. Okay, and the relation is 5 comma 6 and 6 comma 5. Okay, so let's check for the reflexive. Okay, so what are the elements? So 5, 6, 7. So 5 comma 5, 6 comma 6 and 7 comma 7 does not belong into the relation. I'm checking for the symmetric. Okay, 5 comma 6 and 6 comma 5 belonging to the relation. Okay, so this is symmetric. I'm checking for the transitive. Okay, 5 comma 6 and 6 comma 5 belonging to the relation, but 5 comma 5, okay, does not belonging to the relation. Okay, so we have found an example, okay, which is only symmetric but neither reflexive nor transitive. Okay. So coming to the second one, okay, we have to find a relation which is transitive but neither reflexive nor symmetric. Okay, so it should be transitive. Okay, so let's take a set of real numbers, right? And the relation is, so the relation we take it as a comma b such that, okay, it's a less than b. Okay, so let's check for the reflexive. Okay, so if you take a comma a less than a, so a number cannot be less than itself, so it is false. So this is not reflexive. Okay, so let's check for the symmetric. Okay, for example, if we take a comma b, a less than b. Okay, so if we take b comma a, okay, b less than a, so this is false, right? Since a less than b, b is greater than a, but what we get, b less than a, which is false, so this is not symmetric. Okay, so let's check for transitive. We take a comma b and b comma c. Okay, so a less than b and b less than c. Okay, so we get a less than b and b less than c. Therefore, a less than c is true. Okay, therefore a comma c belongs to the R. The given relation is only transitive but neither reflexive nor symmetric. Okay, so coming to the third one, okay, we have to check for reflexive. Okay, we have to get a relation, okay, which is reflexive and symmetric but not transitive. Okay, so let's consider this set a equal to set of 4, 6, 8. Okay, and the relation is 4 comma 4, 6 comma 6, 8 comma 8. Why I have taken like this? Because it should be reflexive. So I have taken 4 comma 4, 6 comma 6 and 8 comma 8, and it should be symmetry. So I have taken 4 comma 6, 6 comma 4, 6 comma 8 and 8 comma 6. Okay, so let's see. So reflexive. Okay, so 4 comma 4, 6 comma 6, 8 comma 8, so belonging to the relation. Okay, so checking for symmetric, of course 4 comma 6 and 6 comma 4 belonging to the R. Okay, so checking for transitive. Okay, so 4 comma 6 and 6 comma 8. Okay, so we'll take this 4 comma 6 and 6 comma 8 belonging to the R, but 4 comma 8 does not belong into the R. So this is not transitive. So this is the example of relation which is reflexive and symmetric but not transitive. Okay, so coming to fourth Roman, okay, we have to give an example of relation which is reflexive and transitive but not symmetric. Okay, so let's consider this. Okay, A equal to set of real numbers. Okay, so the relation is A comma B such that A cube less than or equal to B cube. Okay, set for reflexive. Okay. Okay. So if we take A comma A, okay, A cube less than or equal to A cube. So it is true. Okay. So this is reflexive. So let's check for symmetric. So if we take A comma B, then A cube less than or equal to B cube. Okay, if we take B comma A, okay, so B cube less than or equal to A cube. So this is false. So this is not symmetric. Okay, so let's check for transitive. So if we say A comma B, then A less than A cube less than or equal to B cube. Okay, so B comma C, B cube less than or equal to C cube. Then A comma C, A cube less than or equal to C cube. So this is true. Okay. So this is the example of relation, okay, which is reflexive and transitive but not symmetric. So coming to the last Roman, okay, we got to give an example of a relation which is symmetric and transitive, okay, but not reflexive. Fine. So let us take, okay, a set of minus 5 comma minus 6. Okay, so the relation is given as minus 5 comma minus 5, okay, minus 5 comma minus 6. So minus 6 comma minus 5. So why I am taking like this? Okay, it should not be reflexive. So I have taken only minus 5 comma 5. I can take minus 6 comma 6. Okay, it should be symmetric. So minus 5 comma minus 6, minus 6 comma minus 5. It should be transitive too. Of course, minus 5 comma minus 6, minus 6 comma minus 5, then minus 5 comma minus 5. So just I write the statement. Okay, so reflexive. Okay, so minus 5 comma minus 5 belonging to R, okay, but minus 6 comma minus 6 not belonging to the R. Okay, so checking for the symmetric. Okay, so minus 5 comma minus 6 and minus 6 comma minus 5 belonging to the R. Okay, so checking for the transitive. Okay, so minus 5 comma minus 6, minus 6 comma minus 5, then minus 5 comma minus 5 belonging to the R. Okay, so this is true. So this is the example of relation. Okay, so which is symmetric and transitive, okay, but not reflexive.